going to package a web application, actually a web shop to sell used socks with Nix, which is an interesting tool. So my name is Maarten Hoogendoorn, and that's my Twitter and GitHub account if you want to look me up. I'm a research engineer at Container Solutions, and I will slightly diverge into what I'm doing at Container Solutions, which might help explain why I'm interested in this Nix tool. So at Container Solutions, we have two types of clients. We have end users who actually build proper products, and we have vendors like Chef or Google that we about their products and help them whatever, write documentation or experiment with this tool, etc. So the goal for our user clients is mostly to improve the time to market and to enable experimentation. The end goal, of course, to make more money. The means that we employ to get them there is to help them move towards a CI/CD pipeline solution. So for some companies, the first steps will be just to add more automated tests and... Oh.
It's open.
Oh, okay.
Why didn't I
mic?
Yeah.
I actually prefer to talk without.
Okay.
Am I clear enough?
No, you were really soft.
Oh, too soft. Okay, in that case I will just use this one. Do you have to restart?
No.
Okay. So we are helping our clients to improve time to market by implementing CI/CD pipelines and working on cloud-native architectures. And the technology they mostly use is actually Docker to package their systems, and they are mostly moving from bigger monoliths to actually microservices that are deployed on top of an orchestrator like Kubernetes or Mesos. However, this talk I'm going to talk about something entirely different. It's called Nix, and that's because we like to learn a bit about technologies that are not really used but are just interesting for the technical differences. And the sock shop, I'm going to package it with Nix, but it is mainly going to be a vehicle to talk about this Nix tool. So really, it is all about Nix. And what the stuff that I'm going to cover in this talk is to show how I can build and deploy code with Nix. I'm not going to talk about the continuous integration server Hydra and binary caching, which is quite interesting, but maybe for another talk. So this sock shop is what we call a reference application. It's just a small example of how one could set up a microservice application. We have one front end and several backing services that provide different services that the front end consumes and presents to the end user. As you can see, it's implemented in different languages. We have some in Go, some in Java, and I thought there's also an implementation of the re-implementation of the same service in .NET, and I think we also created one during hackathon, the payment server in Haskell. So to summarize, this sock shop has many different languages, and not only that, there are actually manifests to deploy this one application on top of multiple targets, on top of Kubernetes, Swarm, Mesos, ACS, the Elastic Container Services from Amazon, and some others that are not that relevant. But the main constant here is they are actually all packaged as Docker containers. And I want to change that. I've packaged them with a different set of technologies. So Nix is a word, and it's a bit confusing, so I'm going to explain what it is all about. It's a set of tools with the scope to, as I said before, to build and deploy packages. And it's not only about just creating your small local package, but actually capturing all the dependencies of your program that you want to deploy. And second, it is also a configuration management system, so you can throw out Ansible and Chef and Puppet, etc. Nix will take care of that as well. On that level as well, it takes over what you would normally do with Terraform. It is able to actually create resources in the clouds, which you then can configure using the configuration management layer, and you will deploy your packaged applications on top of that. So the tools here are the Nix, the language itself. Then we have Nix packages, which is a bit like Homebrew if you're on OS X. which is a curated set of packages, descriptions of how to build them, expressed in this Nix language. Then we have NixOS, which is a Unix distribution that builds on top of these packages again, but it sees the whole current version of your operating system as being one package. So that means that you can very simply just update to a newer version of your, let's say, your developer laptop office or a server, and actually the previous package is still saved. So in configuration management, you often have the problem that you want to undo something in a account, but with NixOS, you just switch the version of your entire system and actually you can. And NixOps, Nix Operations, is a tool that you can use to create resources in clouds. And then with NixOps, you can, NixOS, sorry, you can then manage what is actually running on the machines you provisioned with NixOps. So you could ask, well, why bother with all of this? Because we already have stuff like Terraform or CloudFormation and to create resources in the clouds, and Ansible, Chef, and Puppet and other tools to actually change your operating system. And even there are different tools to package for application like Docker or Rocket or any other container system. Well, the answer is that Nix is a simple language, and it's one language that you can use to go through all these stacks from top to bottom. So recently a colleague of mine, he played a bit with trying to integrate Terraform with Ansible, and there he had to write some wrapper scripts and do stuff to convert data formats from one tool to the other, and it was a bit of a hassle. So in Nix, I believe personally that those things are a bit easier to do. So let's go a bit deeper into what managing dependencies actually entails. Let's say you have a Python application, then typically you have, let's say, requirements.txt in your Python project that describes the actual Python dependencies. But let's say you have an AG that actually uses libxml, which is usually provided by the operating system, as it's going to link to it through a foreign function interface. And maybe it does some graphic processing and it shells out to the graphics program. So in order to run this Python program, you need both your Python code, libxml, and graphics. In the old ages, before anyone did any configuration management, you just had a sysadmin just apt-get installing all the stuff until it worked in the basement, and you weren't really sure what was on your server in the end. To solve that, configuration management started to become more popular. And in a nutshell, configuration management is that you have some state, and then you run your conversion process like Chef, and you have some instructions that it will execute, like add a box. Then you will get to a new state where you actually have the box. However, if, let's say, a few days later you decide you do not need this box program anymore, you can't just remove the declaration, install box please. You actually have to take an active step. You have to say, please remove this box for me. And that's not all, it's even worse. In those cases, you often have some cruft left behind, some configuration files or some data that you're not easy to get rid of. So if you want to add a box and then later decide, no, I don't want box, I want circle, then you first have to do an additional step. And in the end state, you might have some cruft left. Docker solves all of this. In Docker, you can simply say, well, I have some base state. First, I decide to add the square, and then we are there. And if later on you decide to just remove, modify that line in your Docker file by circle, it will just go back, right? That's the image layer caching in Docker. Sorry. However, there are some problems there as well, namely, to be precise, composability. So if you have the base state and I decide to install two different programs, program 1 and program 2, and then I want in both to install program B, what is going to happen that you're actually getting a completely new state where B is stored twice. Right? There's no way around that to do it in Docker containers. So it's a small intermezzo. Let's take a look at what we have seen so far. You've seen no management of state. Then we had the linear states in configuration management systems like Chef and Puppet. Docker is basically a tree, You can build very complicated systems, and if you just change the last few lines, you can basically reuse all of it, which is very, very fast. That's why it's pretty awesome to use Docker. The next step, I would argue, is that you would have systems that are a bit more complicated, that look like graphs. And that's actually precisely the model that is behind Nix. So in Nix, you just declare what you want to be in your system in the end. So in these two blue circles, I declare two different system configurations, and I say let there be a purple square and let there be a orange triangle. And then I will just let the system figure out where they have to come from. So it's not imperative. I'm not saying please add this first, please add that first. So in this system there is no meaning of installing square first and then triangle or vice versa. It just declaratively states please make sure that both of them are in there. And then it will just grab them somewhere from the environment. We get back to it a bit later. Exactly here. So let's say that this blue circle represents my laptop and I want to have two things installed. Vim, because I want to edit my files, of course, and my application. And my application is actually implemented in Rust, which is a very cool programming language. So what is all going on here? My application, the end result that I'm going to install on my machine, has a runtime dependency on Graphics and libxml. And it's going to link this via, say, shared object, and sorry, the other way around, this one, and it's going to shell out to Graphics. And it also has a build time dependency on the build environment of my application in blue here, which consists of the build instructions. In Rust we usually use the tool called cargo, so you type cargo build, it's in your build instructions. And of course you need a compiler, a Rust compiler, your source code, and the crates, which are basically the libraries you can use from the internet. So as you can see here in this graph, we can make a very clear distinction between actually your runtime dependencies and your build dependencies. So during your production system, if you're going to deploy to your production system, you can just only bother with this part if it's built, right? You can forget about the build dependencies. But vice versa, if you are doing development, we can get a very interesting benefit of this system, is that we can invoke something called NICShell, which will create a development environment for your application where you will have both the build instructions as the build environment dependencies as the runtime development, runtime dependencies in place. What I've seen is that actually lots of people are using Docker to automate their CI and production developments, but they are still depending on, let's say, their libxml from their local operating system. And that is potentially a source of bugs and problems that you will not find out until you finally get your code into CI, right? So my take-home message from this is that, well, layers are actually quite nice, but there's an ordering there. You can only stack them one on top of the other. As a system for composing components, it's actually a bit poor. Crafts to compose a lot better than that. So I would like to show some demos of exactly this demonstration, then with Ruby. I will show how to package a Go application, and in the microservices demo, it was actually packaged in two different ways using two different Go vendoring tools. And I wrote two small snippets to actually support that. I can show that. And finally, we have a Node application that I'm going to show. So let's do that first. So I have a very, very simple Ruby application, and in my gem file I have only one dependency. It's called nocovili, which is a wrapper around libxml, so you can read XML files really, really fast using this C implemented library and access it with the use of Ruby. And I have a very simple program that does nothing except printing that it has successfully loaded. So by default, if I would run this on my machine, it will just crash immediately. That is because I have not installed notebook here somewhere. So what we can do now is convert the dependencies written in here to a file that's called a gem set. So that's actually all. It already did that. And what it contains is not just the version and the name of the gem you're going to install, but where it is coming from, and most importantly, it's going to store a cryptographic hash of the dependency. So in Nix, all things are identified by a cryptographic hash. That means that if you would build this dependency once, it will never be built again, because we are really sure that it is still the same, because all inputs in the system are cryptographically signed, and if you combine two inputs, it will output a new hash, and that operation does not have to be repeated then either. So I can build this application and this is a no-op actually. What's it again? Oh. There should be a command to just remove one. Anyhow, I can make a small change which will, by definition, then actually change the input to the system, and therefore it will not consider it to be the same. And if I would rebuild it now, it will actually do something. And given that this is a Ruby application, it's basically a recombination of source code, but it would start downloading stuff if I would add an additional dependency to my gem file. So what's the whole point of this? I can also enter this NICShell which I talked about before, and now all my development dependencies have been made available. So now actually the libxml is brought in my current context, and this might not really look exciting, but the very exciting thing here is that it is exactly certain which version of libxml is going to be used. And Nix is supported across both Linux and OS X. That means that you can do native cross-development with exactly the same versions of C libraries, only they are of course compiled for different targets. So if there is a bug in just one version of the, let's say for OS X, you're still in trouble. But most developers on OS X will know that sometimes they really ship outdated software like Bash, which is ancient.
Sorry, I have a question.
Yes, sure.
So I don't know that much about Ruby, but in Python, if there's a Python library that requires libxml, the Python library itself won't have any code that says I need libxml. It'll just tell you need to apt-get installed. So how does Nix know?
Perfect question.
That?
So there is this tool which I just started, which is Bundix, which is converting this gem file to the gem set file. There is, however, your point is, how does it know that it needs libxml? This is the answer. We have a pre-specified set of dependencies that we know what they exactly need as, in this case, both libxslt and libxml.
Okay.
Right? So what happens here is some magic, making life for Ruby developers a lot easier. That for quite some gems that are used by lots of people, we actually know which operating system provided libraries are needed. And if you need your own, you can specify something exactly like this yourself to the gem set. Actually, I think Yeah, it's an optional command to this bundler env. You can provide something like overrides and then I don't know exactly. Something like this. This is not going to work, but this is the gist of it. So really specifying exactly what you're going to need and what you're going to build. That's the first example. The Go applications are a bit in a similar vein.
A question.
Yes.
But you say that the dependencies are in your environment. So is there just a directory where that it loads into the shell, or?
Yes. So NICShell is actually this is my current path, and if I'm going to enter the NICShell, then it is going to add some more stuff. And what happens here is actually, can I see where it is? This is the wrapped Ruby env. So if I would type wich Ruby, it's now coming from this wrapped Ruby env. And actually, if I'm going to see where it's coming from, oh, it's not a link, it's just this one. This is a wrapper script that is automatically generated. And here you will see that it will point to the gem file, which is, as you can see, actually stored in my store and indexed by the cryptographic hash. So if my gem file would ever change, it would re-trigger the build. And from that gem file, we create the bundler. Oh, this is just the, how do you say it, the bundler directory where it's installed. But this gem home contains all the gems that I have automatically installed within the store. So it's just adding a small wrapper to make sure that it's in your environment. Does that answer your question?
Yeah.
Okay. Go applications are a bit different because it is a compiled language. So let's see which one is a Go application again. The catalog was wrong. So the problem with Go is that there is no standardized packaging system yet. So everyone is building their own vendoring tool. And I encountered two new vendoring tools that I did not know about before when I started doing this. One is called GVT, Go Vendoring Tool. And yes, what it actually does is that it writes a file in the vendor directory, and what it does, it writes down where it is coming from, which revision it is. It's from Git. But what it does not include is a cryptographic hash. So I can't use this as an input for Nix directly. So I wrote a very small Go program called GVT to Nix, which using some Go magic. This is my first Go program, by the way. It's an interesting language, it's cool. It reads the manifest because it's a JSON file. I can just serialize it into the data structures, and then it will walk over all Git repositories in there, and it will call this Nix prefetch Git, which will both download the Git repository and store it in the Nix store, so it's available for later usage until it is potentially garbage collected. And then I will somewhere, I believe, get, here it is, the SHA-265 of this output and write that to a new JSON file that I will later ingest. So what you would typically do is, if you're going to package something with Nix, you use some language-specific package manager that is quite often not as precise as you would like, in my opinion. You just run a very small tool. It generates a file that is, again, later interpreted by Nix, so it can set up the perfect development and production environment. So as a side effect, during a build in Nix, a program cannot access the internet. So npm install will not work. That is to really make sure that the compilation process only depends on what we give to this program. It's even possible with what we call pure sandboxes to create a sandbox where only the /nic/store paths are mounted, so you can only see what is exactly provided, and that's a pretty strong guarantee. Yeah, so Node application is. Are you interested in seeing which one did you go to before? It's the catalog one. So here, in the end, you will not touch this GV2 at all. What you will basically do is call into this tool. It's not into Nix packages. I haven't streamed it yet. So I am just importing it like an echo statement in Python, and then I'm calling the build GVT package, which is just going to eat the manifest, and then sorry, we have this dependencies SHA. So if I would change this one to 5 and try to rebuild it. Then it is going to, as you can see, starting to fetch all the dependencies and store them in the value directory. But it's going to fail because I changed the hash to an invalid value. Let's give it a few seconds. So this is actually a very interesting property that you are really sure that your upstream hasn't changed over time. You don't have to keep everything downloaded yourself, but at least you will be notified if something has changed. Come on. Otherwise you have to just take my word for it that it's going to fail. You can look at it later, or like there. Ah, there it is. And the error it gives is that indeed it says it has this hash ending on 24, but we got this hash ending on 25. So if I would change it back to 24 and I would run this build thing again, it's immediately done because it already knows that this hash has been computed before. So that's another thing I really like with Nix. If you run the continuous integration server high time, then it will just have lots of partial builds already, so your CI system is really fast. Whilst if you would just use a pure Docker system where you would rebuild everything, it would indeed, for every commit, every pull request, rebuild everything all the time. Again, it's nice to have composability. So I would like to show, we can export to Docker or ACI images. So if you have a Docker infrastructure, you could actually keep using that. So you could create Docker containers with this and deploy them on Kubernetes, for example. There is something else called Nix containers. Given the time, I'm not going to explain that. It's a bit like Docker containers, but it doesn't use Docker and layers, but just Nix. I'm directly going to NixOps, which is a combination of Terraform and configuration machine. Okay. I restored this, so it's okay still. So what we have here is two things. We have a logical description here in the source.nix application file, which has please import the apps, which I ran before. So this apps file actually contains, I didn't package the whole shop, but I packaged several parts of it. And what it says here is, it creates a dictionary of the packages that I have. So I make them available here as socks-apps. And what I'm doing here is defining several machines. So this part from here to here defines one machine. From user to here defines another one. User DB from here to here defines another one. And as you can see, it basically reads almost like it is JSON, but actually it's a fully it's a programming language that you can express anything in theory. So on this machine, I am actually defining a systemd unit declaratively. That means that if I would remove these lines and rerun NixOps, then it would also automatically remove this systemd unit. No need to actually do an active step to make your system go in sync. So I'm doing some hacky things like disabling before I want to make something at least. And besides from defining your own systemd services directly, we have a module system, and there are lots of pre-provisioned modules in NixOS, like a module for the service MySQL. So I can just say on my machine service.mysql enable, and it will enable a MySQL daemon. And I can even pick which version I want to provision. And by default, I'm picking the default, which in this version defaults to MariaDB. And I can even have an initializer for databases. So if the database socksdb does not exist, it will just import this database dump, which creates some tables and enters some data. Okay.
Is this a layer on top of a structure layer on top of Terraform, Ansible, and whatever?
No, it's something entirely different.
Yeah, okay.
But as you can see, it mixes both defining your machines and actually configuring them, what is really on your machines, which is something that is interesting because you can just modify this file and rerun NixOps, and it will not tear down all your machines and rebuild them. Because the idea in Terraform is that you need to make your machines immutable, but in Nix, we call that the activation is immutable. We have basically one symlink which defines what is currently running. So on my laptop, for example, we have this symlink, that's my profile. And if you take a look at that, it's actually pointing to that directly. I'm getting into the nitty-gritty details, but basically how it works is that we build packages like trees, and then in the end you have this one package again that we just put in the path, and it contains all symlinks or binaries that you want to use. And you can, since one of the few things that on Unix are truly atomic is switching symlinks. We truly have atomic upgrades. So if you would apt-get update something and a list happens, apt is actually going to write files one by one. So if you're in bad luck, you actually might get, if apt crashes, you will get stuck in some limbo state, which by construction is not possible in the system.
Another advantage of that is that you can have two different versions of the same package or library installed.
Exactly. Actually, it's very easy. And try having different versions of glibc on your Ubuntu machine is horrible. It's basically not possible. We have a utility for that called patch-elf, which is actually reused to so the context here is if you want to run, let's say, a binary that is produced by your neighbor and it's closed source and you can't use it without, you can't recompile it yourself, then we use patch-elf to actually set some variables in the elf executable to make it run correctly. But indeed, you're correct, we can have multiple versions in parallel, very easy. So that's the demo of NixOps. The logical part. What I'm going to show is that you can actually use this same definition to deploy both locally on VirtualBox. So this is going to be fun. How did I name them again? NixOps deploy -d VirtualBox socks. There it goes. So I cheated a bit. I already created the VMs before because otherwise it is going to just take too long. What actually is going to happen is that it is spawning lots of VirtualBox machines. So yes, you can disable this, but it's so nice to during demos that you can see lots of text moving around, right? Okay. Oh, it's actually going to deploy something interesting. So, oh, this is horrible actually. Demo effect. So what is happening here is that because I stopped my VMs, VirtualBox machines, and restarted them, I guess that they actually came up in a different order and requested a different IP in a different order, making this all fail miserably. But I can at least show how you can destroy stuff. If nothing works, you just destroy all the stuff, right? Confirm. Yes, I am really sure. In parallel, we can at least show that it is working as well. Yeah, maybe we can just show how you can actually. Yeah, so now I've deleted this NixOps deployment, and I can actually create a new one. Create vbox socks.original and take exactly the same name. And I want to have the socks again. NixOps deploy vbox socks. There we go. And I should disable full screen again because there are lots of VMs going to be started again. So in parallel, I'm going to show that this is the file, right? The vbox.nix that I just typed in, which defines what we call the physical model of your deployment. And it says, please deploy to my VirtualBox thing. And that's not very exciting. What is more exciting is that we also can deploy to things like Google or EC2 or Hetzner, which is a thing in Germany, just over the border. Someone contributed that. And I'm actually introducing some abstraction and computation in here. So here in the end, this is basically the same, right? We have the front-end user database, catalog, etc. And I say that they are all equal to common. That means that they will be the same physical machines. Not exactly the same, but I mean created from the same template. It's called common. And this common template is actually, this is the body of it. And this first part is an argument. So it says, it takes in resources. These resources are defined below here as well. So this is a weird binding. What happens is this is evaluated once to actually create the resources, and then it is evaluated again, and then some more settings are applied. But it is all transparent. And it figures out, out the dependencies of things like it should create your network first, then it will start creating firewall rules and SSH keys, and then only it will start creating disk images and the VMs. So as you can see here, I am creating a firewall on this network to allow SSH, very important, otherwise after you have created machines you immediately can't access them at all. And I'm allowing HTTP as well, every one of them. And pinging is just very nice, so why not? And as you can see, I'm injecting here credentials. This operator is like the merge. It merges the credentials into the rest of my options here. And I've defined the credentials at the top here, which is my key, service account, and private key here. So what's the point of defining this right here? First, it will create all of the dependencies, the networking rules, etc. And then it will start to make the VMs, and then it has access to, let's say, the cloud IDs that have been created before by these two. And then I can just say, well, this network is just this symbolic name, instead of copy-pasting stuff from the GCE output command line. And creating that deployment is just as easy as the other one. Actually, I already did it before. Because provisioning VMs just takes some time. Well, I guess it's blocked. Yeah. It's just a Python application, and at the moment it's not perfect. All of this, it's very interesting, but it's not perfect. So what it's actually doing is it is holding a log to a SQLite database that contains some settings. So I've actually pull requests in the works to make it a bit more like Terraform, because in Terraform you have this awesome feature that you can store the state of your deployment, not on your local laptop, but in a cloud system. Like they store the actual artifacts on S3 and they use DynamoDB for logging. And that works pretty well actually. Yeah, so what you see here is that it created a new package that represents the operating system, and then it applies it and it diffs what should be restarted, and then it's happening. And it says successful. No thanks. No, I don't care about VirtualBox anymore. I already deployed on Google Compute, so we could just otherwise see a bit about what's running there. And indeed, what we see here is it's still big enough. No, it should be a bit bigger. This thing is my network with some cloud resource ID. Then it creates a bootstrap image and different compute engine instances. And this is the IP address of the front end. And if I would curl this one, then indeed I would get some HTML back. That's the Node.js application that we deployed. Yeah, more VMs.
Could you elaborate a little bit, like what's the advantage of doing the Google Cloud declaration in Nix versus, for example, doing it in Terraform? To me, it seems like the application declaration and the cloud services declaration could be separate.
Terraform is very religious about, HashiCorp is very religious about Terraform not being a language that you can compute anything in, right? You can just have very simple lists over some parameters in there. That means that it is very hard to write, let's say, a function that says, please make me a Kubernetes cluster. Whereas this is a full programming language, and actually I plan to write a blog post about this soon, that I can just have add in here, so I need to create multiple machines, so I could say, build me a Kubernetes cluster with 3 masters and 10 minions. That's a bit hard to do in Terraform. I don't think you can do that exactly like this. It's very easy to compose and mix and match things in this system. And the very nice thing is, because it is a pure functional programming language, there are no surprises either. It's once something is building and it works, you will know that it will work forever, and until Google changes their APIs, of course.
I'll do what's the effort on keeping track of all the changes in the APIs for the different founders?
I think they are quite conservative in changing stuff.
It's probably the same as Terraform, isn't it? They also have to do public changes.
Yeah, sure. Yeah, but the only thing is that this is a project that's a bit smaller still.
Yeah.
So in Terraform, probably people have actually added more resources. But it's an open source project, it's implemented in Python. I've added some resources myself. It's not too hard actually. Yeah, so to summarize, what is Nix, what have we done? I've shown how you can build stuff with Nix, and then you can be really sure that it's actually what you're building is in there, which has several advantages, like for auditing and security. You basically only have to verify, to communicate one hash and check it beforehand, and then later on you can verify that this hash is indeed correct. And then you're basically, you don't have to rebuild everything or check all the content of the files, but you can just traverse those trees directly. I've shown how you can deploy some stuff, and maybe another time I could talk about Hydra, which is a continuous integration server. I don't know that much about it myself yet, so I should learn more about it. And binary caches are an interesting feature, which means that a build farm will build Chromium for me, unless I want to change some flag. So it has both the awesome advantages of Gen 2, where you can just make, change any flag you want, but there are default values, and if you stick to default values, it will just download a pre-compiled binary, which is lots and lots faster than compiling Chromium.
How does Hydra relate to things?
Hydra is the continuous integration server. So we have something called
But like, is it just another continuous integration thing? So how does it relate
It's really
specifically
specific to Nix. It's really specific to Nix. There actually there are some initiatives to rewrite it because it is a combination of Perl and C++. But you know works, right? So, apparently not at the moment. But it's a nice tool. I just should take a better look at it. The main reason that I have not taken a look at it already is because the documentation for this tool for Hydra is lacking. So in general, the reference documentation for this project is really, really great, but it's a bit hard to get started because there are not really clear manuals. Yeah, so to summarize, it's one language to rule them all. You can do everything with it, from building packages to managing your operating system to actually managing cloud resources. It's really predictable. It's a pure functional language. If you add a number to it and it does some computation, it's not going to launch missiles, it's only going to return a result. It really offers more identical development environments than anything else that I know of with the comparative ease. Disadvantages. So, my experiences with Nix have been either it is very simple to make it work, like those Go projects, or it's not going to work at all and you're spending like 2 weeks, which I tried with G-Cloud because it tries to download stuff on its own. So it's like self-modifying code of the 60s, right, on mainframes. I do not want my program to install more stuff in its local directory. I want an external system to manage that. It's a smaller ecosystem, so there are less people actually working on it. And yeah, as I said before, the reference manual is really great, but there are really not guides that take you by the hand to make you understand what's going on and how you can use the system in a practical way. So what's next? If you're interested, there's a very, very friendly community on Freenode, on IRC, on the NixOS channel. I'm there quite often myself. There's an emailing list. I haven't linked to it because it's one of those horrible Gmail. Actually, it's not, but anyhow, you can find it on the project website. And I'm running a Nix meetup, and yeah, if you want to learn more, we are probably going to organize another workshop soon. So sign up and then you'll be notified. Thanks. Do you have questions? Left. No questions?
Thank you very much.